Hello everyone, welcome back to another daily Leetcode challenge. Today we will be solving problem 231, which is a power of 2. So we are given an integer n, and we want to return true if it's a power of 2, and otherwise we want to return false. So an integer n is a power of 2 if there exists an integer x such that n is equal to 2 to the power of x. So we can look at some of the example here that's given. Let's say the input of n is 1, then it is a power of 2 by, it has represent a power of 2 by 2 power 0 here. And if it's equal to 16, then we're supposed to return true because it can be represent a power of 2, it's a power of 2 of a power 4. And if it's equal to 3, we want to return back false because it cannot be a representative the power of 2. Yeah. So there's a follow-up question here saying that can we solve it without loop recursion? So essentially, we're going to be solving it in a brute force approach first, which will be using loops. And after that, I'm going to show you a more optimal way how you can solve it without using loop. And that's we need to use a bit manipulation. Okay, now let's look at how do we go about solving it in a brute force way. So let's take a look at these two examples. We have n equal to 1 and n equal to 4. Both of them can be used to represent a power of 2. So the brute force way that we do is we're gonna iterate loop. We're gonna have a loop starting I at 0 all the way until n. So if we iterate for the n equal to 1, then it means that our I will be looping through only 0. And for n equal to 4, our I will loop through iterate through 0, 1, and 2. So, and in every iteration, we want to check if the 2 to the power of that I is equal to the value of n. So in this case, we can say at this first iteration, 2 to the power 0 will be equal to 1. That means it equal to n, and that in that case, we want to return back true. And also, for the case where n equal to 4, we will be looping through this three number. So 2 to the power 0 is equal to 1. No, is 2 to the power 1 is equal to 2. No, it's not equal to n. And the last one, 2 to the power 2, will be equal to 4. So that means here we return true back. So yeah, so this is a kind of naive approach that you can come up with. And the time complexity of this brute force solution is O of n time. But there's a follow-up question, as I mentioned. So we don't want to use loop, and we want to have a better time complexity. And how do we do that? I'll show you in the next example. All right, so now we can have a look at the pattern, how we can come up with an optimal solution. So we can see like the number that is a representation of the power of 2, they kind of like they have only one bit. If you see this pattern in the example here, so let's say to the power 1, the representation of its bit is 001. It has only one digit. And to the power 2, it's only have one digit here as well. And to the power 3, it's only have one digit inside the whole digits. So like this kind of like pattern will hold for every number that is a power of 2. So how can we kind of like take this pattern and come up with optimal solution? So the trick here is we're gonna use a bitwise AND operation. So let's say we have our n equal to 8. We're gonna turn that into a bitwise a bit binary representation, and that will be 1,000. And then we're gonna take the n minus 1, which is 7, and we get the binary representation of it and do the bitwise operation. So the result of this bitwise AND operation will lead us to 0 if you look at the table on the right here. So bitwise 1 and 0 will eventually give us 0, and this will give us 0, and this will give us 0, and this will also give us 0. Yeah, so we can take a look at another example when n equal to 1. So the binary representation is 0, 0, 0, 1, and it's n minus 1 is 0. So we do the bitwise operation on this 2-digit, and what we get is 0 as well. And this is the binary representation of 0. So that means our optimal solution is to kind of like take the n integer, the input of n, and then do the bitwise between n and n minus 1. And if we get the result of 0, that means this number is a representation of the power of 2. Yeah, I think that is mostly it about how the optimal approach. Now we can get into the coding part. All right, now we can start our coding. So the first thing that I want to do is create a function. This function, we will have two solutions. One is the brute force, and another one is going to be the optimal solution. But I'm going to write the brute force first to show you how it looks like. So I'm going to define a brute force function here, and that will take the parameter of n, and this will be a loop. So for I in range 0 all the way until n, we will check if the power of 2 of any I within the range, power of 2 of that I is equal to the n here, we're gonna return true. Otherwise, we just return false. Yeah. So that is pretty much it for a brute force solution. And I'm not gonna run this function because this will eventually leads to time limit exceed. That's why we need a bitwise operations. So I'm gonna define another function called optimal bitwise, and that will take a value of n. And what I want to do is to return back the n bitwise n operation, which is n and n minus 1 is equal to 0. But there's one edge case that I need to check. If we need to check, we need to guarantee that n is bigger than 0, because if n is 0 and n minus 1 is minus 1, then that's not gonna be set to true. Yeah. Right. I think that is just one line for our optimal solution, so I can just return back the optimal function by taking n inside, and I can just run this optimal function and see if it works. Yeah. My bad. It's just some typo here. Yeah. So let's run again and see the result. Cool. So now it passed some test case. Let's submit it and see if it passed all the test cases. Cool. Now it passed all the test cases. So keep in mind that the optimal solution has the time complexity of over 1, which is very fast. So that's why I was able to beat 100%. So that is it for our solution for the problem today. I hope you guys like it, and please subscribe and don't forget to give me a thumbs up. And I see you guys in the next daily challenge. Thank you so much.